Welcome to lesson number 2. In this video we're going to look at factoring and applications. Now I'm going to skip over this first page. It's pretty self-explanatory, and then it just reviews on how to use algebra tiles. And so remember, algebra tiles are just different ways we can express working with a trinomial. So I'm going to skip right ahead to factoring using the decomposition method. Okay, so in the warm-up earlier on, we worked with this number, 6x squared plus 3x plus 8 plus 4x. Or if we gather these two like terms together, we'll have 6x squared plus 11x plus 4. Now once we factor these numbers, we're going to get 2x plus 1 and 3x plus 4. Now the way we do that is by decomposition. And so in order to decompose this, we actually have to, the term we decompose is this middle term, 11x, and we decompose it to 3x and 8x. And then from here, in order to factor the rest of it, we just use our method of grouping, which we did in the last video. Now, in order to factor 6x squared plus 11x plus 4, we must first split 11x into 3x and 8x. Now the problem then arises, how do we know to split it into 3x and 8x? Okay, so we know that 11x can be split up into those two terms of 3x plus 8x, and that will give you 11x. But how do we know to use those numbers and not something like 11x is equal to 2x plus 9x, or 5x and 6x, or 10x plus 1x, right? Like, how do we know to use these two numbers? Now, the way we know to use 3 and 8 to decompose 11 from 3 and 8 is to look at how do we find a relationship between these two numbers and then the rest of the numbers in our trinomial. Okay, so remember that our original trinomial was either 6x squared plus 3x plus 8x plus 4, or the original, which is 6x plus 11x plus 4. Alright, and so we have to look at 3x and 8x and see what the relationship is between the 6x squared and the 4x squared. Okay, now the relationship then is 3x is half of, or 3 is half of 6, and 8 is 2 times as much as 4. So right away we can see that there is a relationship between those terms. Alright, so that's how we know to use 8 and 3 rather than, let's say, 9 and 2 or 5 and 6. Okay? And so then when if we were to actually write out what this relationship is, 8 plus 3 we know is equal to 11. Or in our long form, 8 plus 3 is equal to b. b standing for the middle term of our trinomial. Alright? And so then if we were to multiply 8 times 3, we're going to get 24, which is the same thing as 6 times 4, or a times c, in this case, a being 6 and c being 4. Alright, so that's the relationship between our numbers, and that's how we know it has to be 3 and 8. So let's look at another example. If we have 12x squared plus 9x minus 8x minus 6, or 12x squared plus x, since 9x minus 8x is just x minus 6, we get 3x minus 2 and 4x plus 3. So then the first thing we need to do is split this term of x. Okay? Now remember, we need to think of numbers where we're going to have a relationship between the 12x and the 6. So in order to factor 12x squared plus x minus 6, we must first split 1x into 9x and negative 8x, and then we have to group them. But again, how do we know to split 1x into 9x and negative 8x rather than 5x and negative 4x or 3x and negative 2? So in 12x squared plus x minus 6, 9 and 8 are connected to the value of A. Okay, so they're connected to the value of 12 and the value of B and the value of C. So all three of those numbers are connected. So let's see how they're connected. We have 9 plus negative 8. We're going to get 1. And so that was our value of B. Remember, if we rewrite this as ax squared plus bx plus c, that is the value of B, which is just x. Okay, so 9 plus negative 8 is equal to B. Now, let's see how they are. 9 times 8 times negative 8 is going to be negative 72. Well, if we look at our values of A and C, if we have 12 times negative 6, that's also equal to negative 72. And so we can say that 9 times negative 8 is equal to A, in which case A is 12, and C, in which case C is 6. Okay, so that's how we know to use 9 and 8 rather than 5 and 4. Okay, so we're looking at the product of our last two terms, and remember, we're looking for the sum of our middle term. Okay, so I think the best way to actually learn this stuff is just to have practice in factoring. Okay, so let's look at this first term. Factor using the method of decomposition and then compare the answers with class examples numbers 1 and 2. Okay, so what we're going to do is let's go through and factor these. So if I have 2x squared plus 7x plus 6, if I use the method of decomposition, this will become 2x squared. I know I have positive and positive on both sides, so I know that all of my terms are going to be positive. Now, the next thing we need to do is think of two numbers that have relationship between the sum of 7 and then the product of A, which is 2, and C, which is 6. So that they're going to have a product of 12 and a sum of 7. Okay? And so if we just think of numbers 12 and 1, that doesn't work. 6 and 2 also doesn't work. 3 and 4, that works. They add up to give you 7 and they multiply to give you 12. And so that's going to be 3x plus 4x plus 6. Now, the only problem here is that I wrote 3x beside the 2x and 4x beside the 6x, which isn't a huge problem, but it's going to be a little trickier when we group these four terms together. So I'm actually going to rewrite this as 2x squared plus 4x plus 3x plus 6. Okay, so now when I group them, I can have a more, well, it's just going to group. Before, the way I have it written out, it wouldn't group properly. Okay, so I'm going to group these two terms and then these two terms. Now if I get rid of my greatest common factor, that's going to be 2x. Okay, so we'll have 2x times x plus 2. And then over here, my greatest common factor will be 3. So we'll have 3x plus 2. Perfect. So again, you see how we have two terms multiplied by x plus 2, so we can have one term of x plus 2, and then we'll group these two, which would be 2x plus 3. Alright, and so that's our answer for the first one. Let's look at the second one, 5x squared plus 7x plus 2. Now, if I look at 7x, what are two numbers, again, that are going to give me a sum of 7, but then give me a product of 2 and 5, or of 10. Now, the only number that is going to give me that, so one way we can think about this is if I multiply it, it gives me 5 times 2 of 10, and when I add it, it gives me 7. Okay, so right away we can think of two numbers. Oh, 5 and 2. Good. And so 5x squared, we're going to group these. Now, where should my 5 be and where should my 2 be in relation to these two numbers? Well, remember, we want to have numbers that have a relationship to each other. So 5, of course, has a close relationship to 5. And 2 to 2, and And so that's what we're going to be left with, and we're going to have to group these. And so if I take 5 out of both of these terms, well, 5x, we'll be left with 5. And then 5x out of there is going to be x plus 1. And I have 2x out of here, and I'm only going to take 2 out of there. So I'll be left with 2x, 2 times x plus 1. And there, my x plus 1s, I'm going to group into 1. So x plus 1 times 5x plus 2. And that's my answer there. Now, the rest of the examples, I'm just going to do the exact same thing. Okay, I'm going to do all these examples just to give you the hang of factoring using the decomposition method. So my first set of numbers are going to be 6x squared plus 17x. Again, let's start by doing this, making a little chart and thinking about the numbers that I need to multiply and add. Okay, so to multiply, I need to get a product of 6 times negative 3. So my product needs to be negative 18, and my sum needs to equal 17. So what numbers are going to multiply, give me negative 18, and add to give me 17? Well, if I have negative 1 plus 18 plus positive 18, that's going to give me 17, and then when I multiply these two terms, I'll get negative 18. Alright? And so, again, we need to think about, okay, well, what is the relationship between these numbers, and where do I put them? Alright, so sometimes you are going to have to do some trial and error, but I'm just going to put my 1 there, or x, plus 18x minus 3. When I factor this, they're both divisible by x, and so I'm going to have x and 6x minus 1 plus, they're both divisible by 3. It's going to be 3, 6x minus 1. So I have 6x minus 1 and 6x minus 1, so those are going to group together. And then I'm going to have x plus 3 right here. Okay, my next one. Let's start off by doing this again. So what numbers are going to multiply to give me 3 times 8, 3 times negative 8, or negative 24, and are going to add to give me negative 2. Okay, so a good way to start by this is just going through your factors. Okay, 24 and 1, no. 12 and 2, no, because they're not going to add to give me negative 2. 8 and 3, no. And then I have 6 times 4. Negative 6 plus 4 would give me a negative 2. So negative 6 and 4. So those are my two factors. How do they relate to each of my n numbers? Well, negative 6 is half, or is double of 3, and then 4 is half of 8. And so there's the relationship. I have 3n squared minus 6n plus 4n minus 8. Okay, so now we can decompose this or group these two terms. The common term here is going to be 3n, so I'll take 3n out of both of those, and I'll be left with n minus 2. Same thing over here, I'll take 4 out of both of these terms, and I'll be left with 4 times n minus 2. And so then my final answer is going to be, I'll group these two n minus 2 terms, n minus 2 multiplied by 3n plus 4. Alright? And that's my final answer there. Now, my last one, 12x squared minus 8x plus 1. So, we'll look at all of these terms again, and again, what numbers multiply and add to give me, first of all, multiply give me 12, and add to give me negative 8. Alright, negative 8. Okay, so I have, let's see, 3 and 4, no, that would give me 7, or negative 1, or Yeah, it's not those two numbers. So let's see, 6 and 2, negative 6 times negative 6 is 12. Negative 6 minus 2 is negative 8. Perfect. So negative 6 and negative 2. Those are our numbers. So then we have to think about, okay, what is the relationship here? 12x squared minus 6x minus 2x plus 1. Okay, so we group these terms again. They're both divisible by 6x. So 6x is going to be 2x squared minus 1. Oh, sorry, 2x minus 1. Minus, what is this divisible by? Remember, we have to take the 1 out in this case in order to make it a nice number to work with, but also to give me two numbers that I could group over on this end as well. Okay, so 1 is 2x, negative 1 times 1, negative 1 is plus 1. So we'll be left with 2x minus 1 since I grouped this term and this term, minus, or sorry, 6x times 6x minus 1. And I'll be left with my final answer right there. Now actually two more examples. 15 minus 7y minus 2y. Okay, so even though it's kind of written in a different order, we approach it the exact same way. Okay, so again, what numbers multiply to give me 15 times 2, or negative 30, and add to give me negative 7? Okay, so we have negative 10 and 3, negative 10 and 3, which will multiply to give you negative 30. Negative 10 plus 3 will give you negative 7. So those are our numbers. Okay, so next thing we do is we group them. So 15. Now this is a little tricky because you could go either way, right? And so I'm going to go like this: 10y plus 3y minus 2y squared. When I group these, I can take 5 out of both of these terms. So I'll have 5 times 3 minus 2y plus, I can take y out of each of these, and that would give me y times 3 minus 2y. 3 minus 2y and 3 minus 2y, good. I have 3 minus 2y times 5 plus y, and that's my final answer. So even though it was kind of backwards, we could still use the same method in order to solve it. Now for B, we have to well, actually, if we have a question like this, where if we were to multiply 15 and 10, and then the number is going to add to give you 5, that's a huge number. It's going to be 150. And so what we can do then is we can right away kind of begin decomposing this by saying, okay, these are all divisible by 5, and so I'm going to take 5 out right away, which would be, if I divide all these by 5, would leave me with 5 on the outside, multiplied by 3k squared plus k minus 2. Okay, and now I can decompose these numbers a little easier. So instead of using 15 times 20, I'm going to use 3 and 2. So my numbers need to multiply, giving me 3 times 2, or 6, negative 6, and they need to add together to give me plus 1. Okay, and so if they multiply to give me a negative 6, and add to give me plus 1, those numbers are going to be negative 2 and 3. Alright, and so then we're going to have 5. I'm going to put a square bracket just to separate everything on the inside a bit better. 3k squared plus, which numbers are going to form a relationship here? Well, in this case, negative 2 and 3, we could, negative 2 and 3, we're going to have, positive 3, sorry. positive 3 there, 3k minus 2k minus 2. Alright, now we can group. So I'm going to have 5. If I look at 3k squared and 3k, these are both divisible by 3k, so I'm going to have 3k on the outside plus, or sorry, times k plus 1 minus, if I have 2k, I can bring out, I can only bring out k, right? Or sorry, I can bring out 2. So if I were to divide both of these by 2, I'm going to have 2 on the outside, k minus 1. Alright, and so then I'm left with 5 times 3k minus 2 and k plus 1. Oh, negative and negative there. Yeah, that's good. Okay, so my next example. The method of decomposition can be applied to trinomials of the form ax squared plus 5xy plus cy squared. Okay, and we actually do this the exact same way. All right, so I look at which numbers I need to add and multiply. So first of all, which numbers do I need to multiply? If I have 2 and 2, they need to multiply to give me 4 and add to give me negative 5. Alright, and so the multiplying numbers, negative 4 times negative 1 will give me positive 4. Negative 4 minus 1 will give me negative 5. Okay, so this is equal to 2x squared minus 4xy minus xy plus 2y squared. Okay, so now we gotta take out the common factor. Both divisible by 2x. 2x, x minus 2y. Minus over here, they're both divisible by y. So I'll bring the y outside on both of them. Y times x minus 2y. And so we're going to be left with x minus 2y. Okay, and so then we'll finish with 2x minus y. Alright, so this next example I'm going to go through pretty fast. So if I have 2n squared and 35m squared, if I multiply these two terms, I'm going to get negative 70. And I need to add two terms together to get negative 3. Now to get negative 70, I can go 10 times 7, which would be 70. And then I can go 10 minus 3, or negative 10 plus 7. And so then in that case, I would be left with negative 10 and 7 as my two numbers. Okay, and so then 2n squared minus 10nm plus 7nm minus 35m squared. I'm going to have both these divisible by 2n would give me 2n times n minus 5m plus, they're both divisible by 7m, 7m times n minus 5m, and then finally I'm going to have n minus 5m times 2n plus 7m. That is my final answer. Okay, my last page. We're going to talk about perfect square trinomials. Alright, so you might want to pause that to get the rest of that. Perfect square trinomials. Now, you might remember talking about these last year, but a perfect square trinomial is formed from the product of two identical binomials. So for example, if you have p plus q squared, this would be, what this would look like is p plus q times p plus q. Okay, so there are two identical binomials. Remember, a binomial is just two numbers. All right? And so if we were to expand this, we would end up getting p squared, right? P squared plus 2pq plus q squared. All right? So the way you do that is p squared. So we just do FOIL. Times pq plus pq plus q squared. Okay? Now if you have p minus q squared, this is going to become p minus q times p minus q. And then in this case, you would be left with p squared minus 2pq plus q squared. Now one way you can remember this is you always go inside term, or first term, which is p squared, plus these terms multiplied by each other, so p times q multiplied by 2 would be 2pq, and then q squared. Okay, so from the above we can see that the first term in the trinomial is the square of the first term in the binomial. So p squared is the first term in both of them, and it's the square of the term in the binomial. The last term in the trinomial is the square of the last term in the binomial, and so that's where we got the q squared from. The middle term in the trinomial is twice the product. So the product being p and q, so pq times 2, because it's twice the product of the first and last terms in the binomial. Okay, so note, in a perfect square trinomial, example x squared plus 10x plus 25, the first and the last terms must be perfect squares. Okay, so these two terms must be perfect squares, and the middle term must be twice the product of the square roots of the first and last terms. Okay, so this has to be 2 times the product of the first and last terms when you multiply them. Alright, so which of the following are perfect squared trinomials? Let's see, a squared plus 4a plus 4. Yes, this is one, because if we were to look at what this is, this is a perfect square. That's going to be a squared. The last term is a perfect square, which is 2. And then the middle term, if we were to take a and 2, multiply them, we'd get 2a, and then multiply them by 2, we would get 4a. So yes, that is good. Let's see this next term. If we were to write x and, well actually no we can't, because look at, not a perfect square. Alright, so we don't have to do any work there. That's just no. This next one, we have a perfect square here and a perfect square here. And then right here, if we take the product of both of these, so 2 times 9 is going to be 18 times 2, you're going to get 36. Alright, so yes. And then we would write this as squared that is 2x, squared that is 9. Since we have a negative here, it's going to be negative 9 squared. Okay, let's look at this one. Yes, perfect square. Yes, perfect square. But if we were to multiply 4 times y, we would get 8y, but we are also going to be left with a negative there. Right? So we can't actually be a perfect square, because if this was a positive 16, then we could have a perfect square. But since it's negative, there's no way we can get like negative 4 times negative 4 being negative 16, right? So this cannot be a perfect square. Now, example 3, or 8. Fill in the blank so that each of the following is a perfect square trinomial. Alright, so x squared and 100. So both of those are perfect squares. So x and 100 being 10. If we square that, 10x times 2 would be 20x. again, we can do the same thing, x and 10, but since we're a negative here, it's going to be x minus 10. So negative 20x. 10 times x is 10x times 2 is 20x. 25x squared is going to be 5x, since that's perfect squared, and 36 is 6. We square that. 6 times 5 is 30, times 2 is 60x. And then 9, that is a perfect square. So we would have 3m plus, now we don't have our last term, right? We don't have this term. So what numbers are we going to have that when multiplied are going to give you 24? When multiplied and multiplied again by 2 are going to give you 24. So the number is 4, because if you have 3 times 4, that's just going to be 12. But if we double that, it's going to be 24. And so then out here, it would give us 16. Then down here we got a factor. Is 49 a perfect square? Yes. Is 1? Yes. Is 16 a perfect square? Yes. Is 25x? Yes. Is 1/9 the perfect square? Yes, it is. 1/9 squared would be 1/3, or square root of 1/9 would be 1/3, and it's going to be 1/3 a. 9b, is that a perfect square? Yes. We would be left with 3b squared.